Continuing 8.1, Systems of Equations, we have example 3. Now we want to try the elimination strategy. We have the steps laid out here. So here's our system. The elimination strategy says that you want to multiply both sides of one or both equations by a non-zero constant. Of course, you wouldn't want to multiply by 0, so that the coefficients of one of the variables are additive inverses. So I want, if this is a 2x, I'd like that to be a negative 2x, or that's 3, I'd like that to be negative 3. So when I add the two equations together, that variable would cancel. So one or the other. I'm not trying to cancel both, but one or the other. So what I decided to do was multiply the second equation by positive 2. So now, when I add them together, 2x, here's the first one, and the one I just now got. When I add these together, notice we eliminate the x variable, that term, because 2x minus 2 plus negative 2x is 0. Add here, I get 5y, and here I get negative 5. So 5y equals negative 5, so y equals negative 1. And now I can plug that negative 1 in either one of the equations for y. Negative x plus negative 1 equals negative 3. So add 1 to both sides, and I get negative x equals negative 2. So x is 2. So these lines cross at 2, negative 1, if I've done this correctly. So we'll check our systems. 2 times 2 plus 3 times negative 1 equals 1. 4 minus 3 equals 1. 1 equals 1. It works in that one. Negative 2 plus negative 1 equals negative 3. Negative 3 equals negative 3. It works in that one. So we can feel good about this point. Okay, that was example 3. Let's look at example 4 and solve this system. It says to use elimination. Now, the first thing I see is a fraction. I don't want to work with that. So I'm going to clear the equation of fractions by multiplying both sides by the LCD. Okay, and so do you see how that's going to clear out that fraction? I now will have 6x plus 12y equals 2. Right, so now I can think about elimination. So I have this is my new first equation. This is my second. I'd like either x or y to have to be opposites. And I see that if I multiply this one by negative 2, my x, I'll have negative 6 here, and I have positive 6 there. So let's multiply negative 2 times 3x minus 5y, negative 2 times negative 10. Don't forget you have to do both sides. Negative 6x plus 10y equals 20. And now I'll bring this one down. 6x plus 12y equals 2. Add. X is eliminated. I get 22y equals 22. So y is 1. And now let's find x. I'm going to use the second equation. 3x minus 5 times 1 equals negative 10. Add 5 to both sides and divide by 3. Okay, so our x-coordinate is negative 5/3 and our y-coordinate is 1. This is not one we would have wanted to graph and try and read the intersection. Okay, let's look at the next system. We can solve this one any way we'd like. I will not use substitution just because of none of these have a 1 or negative 1 coefficient. So I'm going to see if I can't get the same, get opposites or additive inverses for one of the variables. So I think I'll multiply the first one by 3. That would make this negative 12. And if I multiply the second one by 2, that'll make that positive 12. So negative 3 times 6x minus 4y equals negative 3 times negative 4. So I have negative 18x plus 12y. Not negative 3. I should just multiply by 3. I'm not sure why I said negative Signs are already different, aren't they? So let's do that. Let's see if we can fix it. Okay, multiply by 3 times 6x. 3. Okay, so this will be 18x. That will be negative 12y. And this will be negative 12. Okay, and now the other one I said I'm going to multiply by 2. Yes, 2 times negative 9x plus 6y equals 2 times 18. So I have negative 18x plus 12y equals 36. Now I'll bring this one down. 18x minus 12y equals negative 12. Add, my x is eliminated, but my y is also eliminated. And by eliminated, I mean we get 0. And that says 0 equals 24, which is false. 0 does not equal 24. I have no variable. What happened here? Well, when you get this, all your variables disappear and you get a false statement, this is the case where there's no solution. So we can't see it graphically, but this is the algebraic result that tells us that. But here's the check. Let's find the slope and y-intercept of the lines. So if I have 6x minus 4y equals negative 4, I'm going to put it in slope-intercept form. Minus 6x minus 6x. Negative 4y equals negative 6x minus 4. And divide everything by negative 4, and I get y equals, what, 3 halves x plus 1. So the slope is 3 halves, and b is 1. Let's do it for the other one. Negative 9x plus 6y equals 18. So I'll add 9x to both sides, divide everything by 6. So 9 over 6 is the same as 3 halves, and 18 divided by 6 is 3, so m equals 3 halves, and b equals 3. So when you have the same slope but different y-intercepts, what do we know? The lines are what? Parallel, which means the system has no solution. And it's inconsistent. Okay? So algebraically, the variables cancel, you get a false statement. This is the situation.